So let's solve this trig equation. Now, it's tempting to simply divide both sides by sine x to cancel that out, but by doing that, that's a mistake. We'd be losing some solutions. It is better to move things over and to factor. So we have 3 sine x cos x take away 2 sine x is equals to 0. And we're going to factor out the sine x. So we have sine x, 3 cos x minus 2 is equal to 0. We have this times this times this indeed reproduces the line above. And so therefore, what times what is 0? We have case 1, which is sine x equals 0. And we have case 2, 3 cosine x minus 2 equals 0. Recall what sine x looks like. Between, this is going to be pi, this is going to be pi over 2, and we're going to go backwards. This is negative pi, this is negative pi over 2. Sine starts in the middle, it goes up, and then it goes down. And this is going to be 1, and this is going to be negative 1. And going backwards, it goes down, then goes back up. So between negative pi and pi, sine x is equal to 0 at x equals negative pi, 0, and pi. Now, let's focus on the second part. 3 cosine x is equal to 2, moving this over. Divide both sides by 3. We have cosine x is equal to 2/3. And we have a classic trig once again. We tack these kind of problems by writing ASTC. Cosine is positive here and here. You hit cosine inverse of 2/3. We're in radian mode, which is 0.841 radians multiplied by 57-ish to get about 48 degrees. Should be around here. The reference angle once again is 0.841 radians. So between positive pi and negative pi, we have the solutions. We have x is equals to 0.841 radians, and we can also go backwards. So we have another x is equals to negative 0.841 radians. So we have quite a few solutions here. We have 1, 2, 3, 4, 5 solutions.